Swayam Prabha. Digital India. Educated India.
Hello everyone, I am Gaurav Singh. I am a teaching assistant for this engineering drawing course taken by Professor Rajaram Lakkaraju. I am here to resume this course. I will take on from the assembly of the parts we have designed in the software SolidWorks. As we have already seen, you may have learned up till now regarding designing of the parts. So now there is an important thing in engineering to assemble those parts to make one particular full design that may be used. One of such simple household item we can see is a scissor that you can see on the screen. We can identify this scissor as blades, its handle, the pin, the pivot we say, and so there are particularly 5 parts we can see over here that have been assembled to make this particular scissor. You can see this different parts here. Each of these parts we have learned to design in our previous course using these all kinds of tools in the palettes in the SolidWorks software. So this is using these particular parts, we can assemble these to form one machinery, any electronic component, anything. So one of this is scissor we can see. Another simple design we have is, you can see it is wind turbine. It is a very popular source of renewable energy. This device includes blades, turbines, motor, engine, this pedestal we can see. You can see this wind turbine is made of these blades. We can see the individual components of this that is designed on this software itself, and we can see the assembly of this to form the wind turbine. A good feature of this software SolidWorks is this actually works as it simulates the mechanics of solids. You can see the blades, you can see the blades can rotate along the wind direction, the whole this setup, and also the motor may run as the wind will strike the blades. So this is one design. SolidWorks also supports assembly of far more complicated items, like to build this tractor. We can see this build of multiple components that have been accumulated to form this beautiful tractor. You can see these parts of this, the larger tires, the smaller tires, the engines, the smoke exhaust, all those things. This has been very beautifully assembled to form this one tractor. All this assembly includes some very elementary assembly terminologies that we will go through one by one. The assembly in SolidWorks is synonymous to mate here, mate option you can see. So, in assembly section we will learn from elementary to how to insert the components and learn all of these tools that we can see over here. So, let us begin from the start. So, now earlier we have been using this new command to open a new document. We have been working on this part section. Now, when we are going through this assembly, we have to click on this assembly and OK. This assembly thing the window looks like this. To assemble multiple components, we have to insert the components, you can see here. Then going to browse, it will open. So, let us assemble a little how to insert things, we will check these, some examples. So, say this scissor, we will control select multiple things and click on open. In SolidWorks, the first part we can see so in this way we can up till now we have discussed new document. We have been working on this part. So, now we will be working on this assembly. We click on assembly, click OK. So, this window will ask to open some parts. This is the window it looks like for this assembly window. We will go on, we have to go on this insert component, then go to browse. We have to select the parts. We have been will control select all the parts. And we click open. So, these are the parts that were required to build that wind turbine that we have seen earlier. So, in this way we can insert components in this window. The important thing to note is the first component that we have placed in the window, this will remain fixed and it cannot move anywhere. However, the other parts can be moved, you can see. To keep it to make this move, we have to right click this, the object we want. We can click on float. So this will be floating now from now on. You can fix anyone else to make a reference. This is fixed now and all these are moving. So in this way we can make something floating and fix some items. So there are some tools to see this visibility icon. We can see the origin of each of the items. You can see origin of each items. We can see planes from here. You can see planes. Say suppose for this you have to go on this head and show items, click on planes. You can see the front plane, right plane. This is the basic way to import these parts that we have designed earlier. Another way, like suppose we were designing one of the parts like we have done earlier. This is the earlier window you are familiar with, this part window. So now you have designed this part and you have other parts already ready. To use this in assembly, you have to go to this file, go to make assembly from part. So the same last window that we were discussing can be seen here. You can import it like this and then again insert component, then browse and other items that we intend to include. Now to assemble each of these items into one another, we need to know different kinds of assembly that are available in the SolidWorks. And you can see I have already told you this assembly is synonymous to mate in this software. You can see if we click on mate, we can see different kinds of mates here: standard mates, advanced mates, mechanical mates. So in standard mates there are coincident, parallel, perpendicular, tangent, concentric and so on, and higher advanced mates, hinge, gear, rack, pinion, there are many more. So there we will go through each of them. We will go through some elementary mates of them out of these one by one. Let us open a new document, new assembly. I have two blocks here, two wooden blocks we can see here. Now if you want to mate these this puzzle, you can go through mate. We will see here this mate selections has a window, small window. We have to click on that, then select the faces we want to mate. So for first of these is this coincident mate. In coincident mate, the two things that we want to assemble or mate will coincide. Suppose we want this edge to stick on this particular edge. So you can see the preview here. This is aligned with this edge, and once we click OK, this is mated with this. So this is aligned with this edge. However, because of a loose degree of motion, degree of freedom, this can move and can rotate as well. However, the alignment is all same. As I have already told you, this part cannot be moved because on the first item that I brought here was this block, and this is fixed. To make this float, I can make this float. So now both of them can be moved, but to make a reference, we need one of the items to be fixed. So now we can fix this one. Right click on this, fix. So now this is moving and this is fixed. So this was coincidental mate. Another important feature that we generally use this coincidental mate is to fix the origins. Suppose this particular block has its origin, you can see this origin over here. However, the origin of this geometry, origin of this whole window is here. So if we want this assembly to start with origin, we can select mate, the origin of this item and the origin of this item, and this mates here, and click OK. So it is not mated because this item is fixed, and we have already aligned this edge with the edge of this. So if we make this float, so now you can see the origin of the whole plane is aligned with this origin of this box, and now because this is now floating and this is fixed now because it has to be attached with the origin of the plane. This was coincidental mate. The mate history in this assembly, we can see here mates. What we have done is this: the first coincidental mate that was between the edge of the two blocks, and the second one, the mating of the origin of this block and the plane coordinate. So this was coincidental mate, we can see here. Another thing is parallel mate. Let's remove all these earlier ones. Now it's again both of these are free. We'll fix this. The next kind of mate is parallel mate. In this mate, we can make two planes parallel to each other. As of now, you can see these two are not aligned parallel to each other. To make this parallel, we'll click on the small window here then the face 1 and then the face 2. We click on OK, finish mate. The two faces are parallel to each other, this face and the top one of this, they will always remain parallel to each other. You can see it again. This is the mate history. If we remove this, once again mate, we'll select on this one. Now let's select this plane and this face. Now this has become parallel to each other. We'll click on parallel. This is parallel to each other. Anywhere it moves, it will remain parallel. The next kind of mate is perpendicular mate. This is very similar to this parallel mate. Let's delete the earlier one. We'll remove this parallel mate and we'll move on to perpendicular mate. Again click on this small window. We'll see this face. Let's make it perpendicular to this one, or say this one. Click on OK. So now this this face is always perpendicular to this face. Anywhere it moves, but it remains perpendicular to these two. Next kind of mate is tangent. We will have to deal with circles when we are dealing with this tangent kind of mate. Let's load some new geometry to understand this tangent mate. We have a pin and we have a slot. Generally we can see such kind of things in meters, the odometers and all those things, or knobs that require setting of temperatures and other parameters. So what we intend is this pin is supposed to move through this slot, and from a general intuition we wish that this particular surface is supposed to be tangent on this circular cylinder. To do this, we can move this here and we can see how it works. This is supposed to be like this. Let's fix this one and make this pin as floating, but because we have no mating as of now, we can move it anywhere. For now, let's try this tangent mate. We'll go to mate and this tangent. We click on this small window again, select the circular surface and the surface it has to be tangent upon, and we'll click OK. Selecting tangent, we click OK here, either in the mini toolbox, finish. this is now tangent to this. This is now tangent to this surface. However, this we can see this moving because we have not constrained other degrees of freedom for this. So, we need some other constraints to lock this into this within this slot. So, for this we can align the planes of these two this slot and the pin into one another. To do this, we will coincide it again that we have learned earlier. We will go to mate, we will select the planes of these two. These are the two geometry, the pin and the slot geometry. We will check the front plane for this, top plane for this, the pin, and the top plane for the slot. If we control select these two, we will click on top plane for this slot, and the top with control key pressed, we will select the top plane for the pin and then click on mate. It is automatically suggesting to coincide, or maybe we can select other things, but whatever it is suggesting to coincide, it should be good for us. We click on OK. Now you can see it is locked now, and now you can see this moving within the slot, and it is tangent to the slot surface. The two mates we have used here is tangent, the surface of the cylinder and the surface of the slot, and the coincidental planes of both of these, the pin and the slot. So, this was tangent mating that we have discussed. Okay. So, they said that it's 5 minutes remaining.
It's over. So you end
Okay.
it with tangent. Yeah.
हाँ
हाँ हाँ. और next lecture भी कर सकते हैं दादा. मॉड्यूल